My topic is on vaccines, their evolution and hesitancy. So just a brief outline of the presentation. Initially going to talk about some history, going to talk about mRNA vaccines, which, we see with the new COVID vaccine, vaccine controversy, hesitancy, and then evidence-based practices to help improve vaccination rates. So for the origins of vaccines, it was initially thought to be a homeopathic belief where small doses of a sickness would prevent bigger sickness, or the same thing with poisons. We actually saw ancient rulers throughout the East actually ingest different poisons in controlled doses in order to prevent fatal attempts on their life later. The initial big disease process that had a vaccination associated with it is smallpox or variola. So the process was called variolation. And in ancient China, what they would do is they would take some blisters from smallpox, they would grind them up, and then they would actually inhale them through this procedure where, getting exposed, they would get a minor form of the disease and hopefully be protected later on when they did contract smallpox. India had a similar method, but they had a scarification technique where they would actually take the same blisters, they would actually make some cuts within the skin and introduce that lymph that they found from infected individuals. And these techniques actually gradually used the Silk Road to travel west into the Middle East and Turkey and then into Europe. So smallpox has been ravaging humans for centuries, if not millennia. Even in the American Revolution, Washington's army suffered pretty significantly from smallpox. The British did have immunity because they were using the variolation technique for quite some time prior, and then Washington ended up inoculating his army members also with the variolation technique. There were many fatal reactions that would happen because of this. Sometimes they would just get the disease and die from it. And then in came Jenner with this cowpox, where he found that milkmaids would get cowpox and then wouldn't actually suffer from the devastating effects of smallpox itself. So he took his gardener's son, introduced him to cowpox, and then gave him smallpox and ended up surviving. And that's kind of the basis of vaccination as we know it. Pasteur also did significant work in vaccines. He actually had a chicken cholera experiment that he did at the end of the summer of 1881, where he had actually left for vacation, had left a petri dish of Pasteurella multifida on his bench. And when he came back, he introduced that aged bacteria into chickens and found that they didn't die. He actually had a fresh batch that he used after, and he gave it to chickens, both ones that had been inoculated with the aged batch and then also fresh chickens. The ones that had not received anything prior ended up dying, and then the ones who had received the aged batch ended up living. And through this, he got the hypothesis of pathogen attenuation by environmental insult. And this further developed over the next years to decades. Pasteur himself did further work in anthrax and rabies using oxygen and heat therapy to attenuate viruses and bacteria. Calmette and Guerin ended up working on Mycobacterium bovis in an artificial media to attenuate it. And that's where we get the BCG vaccine coming in. And then the yellow fever virus was experimented on by Thaler with mice and chick embryos. So, there's several different life were the original ones that we saw, and those are the ones that used a related animal virus or just some sort of attenuation process, either in vitro or a chemical based. The next big breakthrough in vaccine development actually was with the cell culture revolution in the mid-20th century. What we ended up doing with the cell culture revolution is finding different cells where we could grow viruses, and it was a means of attenuating them. Some of it was done just by chance and luck, that these cell cultures selected for mutants which were less virulent. They also caused these viruses to become more adapted to surviving in vitro versus in vivo and at lower temperatures. So when the same virus was introduced into a human organism, they were less virulent and a stronger immune response was able to be mounted. This was also a lot more efficacious than animal host attenuation, and it was also sterile. There's a bunch of different non-living vaccines that we have developed in the interim time period. Initially, as you can see at the top, we had a lot of inactivated whole organisms. We've tended away from that now and started to use more just subunits or toxoids, parts of cell membranes, the polysaccharides that are there to initiate an immune response. And then the world that we kind of live in right now is, heavily based on genetic engineering with these new vaccines. The first success that we saw was actually in the hepatitis B vaccine, where yeast recombinant was used in order to produce the S protein gene for hepatitis B. Previously, what was happening was they were just using infected individuals with hepatitis B, getting some of their plasma and purifying the S protein from that. In addition to that, multiple different other methods have been used for genetic engineering, just excising different DNA sequences from different bacteria, such as the typhoid and cholera toxins, and then introducing that into vectors, using apathogenic recombinant viruses or bacteria where they take out different DNA sequences, which actually lead to the virulence. And then also reverse vaccinology, where you actually end up isolating antibodies to a specific disease in patients who have already recovered. And then you find the associated proteins that those antibodies bind to. Then you find the genomic sequence for that, and then create a protein based on that itself. This is just a general timeline of the vaccinations that we've seen. And as we see, we kind of tend away towards the live attenuated ones and are more and more going towards the purified proteins or the genetically engineered vaccines as time has passed. So this kind of brings us into mRNA vaccines. This is a brand new vaccine class, has been around for a few years. There's been multiple developments that have occurred over the past years to decade, which has allowed us to use this, being efficient materials for in vivo delivery of the vaccines, high quality mRNA production. They still have a lot of challenges that we do need to overcome. The RNA is still pretty unstable, and that's why these vaccines need to be kept at cold temperatures. There's still some inefficiencies also that we have with in vivo delivery that tweaks are happening to, and then it usually results in an excessive inflammatory response. So the multiple different innovations that have led us to where we are right now, that we actually see mRNA vaccines on the market. The first one I'm going to talk about is just engineering these mRNA sequences itself. As we remember from biochemistry, the mRNA molecule goes from a 5' to 3' region, and then they also have untranslated regions that are incorporated with both sides. What these do is it actually influences the rate of translation of the molecule and also influences the half-life of the transcript itself. And what we've noticed is by changing around some of these motifs from the base ones that we've actually found in the human genome, we can actually result in higher protein production. We're also using a co-delivery method. And what we're doing with that is the vector that we're producing, we're putting in an mRNA sequence of the antigen that is of interest to us, and then also putting in an mRNA sequence of an RNA-dependent polymerase. What this does is we need to use a lot less our mRNA, and the polymerase itself will produce more once it gets into the cell. This results in lower doses of a medication needed, and then also just cheaper vaccine development costs. Optimizing the mRNA production is also a big breakthrough that we've seen. If you look at the image on the right, this is comparing two different paths that we've used from 2017 and then 2019. So not very different in time period. But in 2017, what we were doing was we were taking a DNA template and then using in vitro transcription, we were creating the mRNA sequence. We were using enzymatic capping to stabilize the molecule. And then from that, you would use high performance liquid chromatography to isolate these specific molecules. And then, that would be the product that we would need for the vaccination. The downsides about this is that every single step that you take, you're going to have some sample loss. And then liquid chromatography is also not very scalable and it's very expensive. So that would be cost prohibitive to a lot of these vaccine developments. In 2019, there was actually a proprietary system called CleanCap that was developed. So what this did was you would take the DNA sequence and you could actually make an mRNA sequence with a cap built in. So you're taking away a few steps as a result. As a result, you're also not having as much sample loss. And with using cellulose, which is pretty cheap and abundant, you can actually purify that mRNA sequence that you want. And this kind of helps the process.
How are you?
Good. How are you?
Right. There's many different materials that we're using for in vivo delivery, and this has drastically developed over the past few years. We're using different charge altering releasable transporters. So you have the mRNA sequence within this complex, and as soon as it gets into the cell, it will actually dissipate based on different mechanisms present within the cell itself. This is actually being targeted right now for some tumor therapies with T cells. The one that we're using right now with the Pfizer and Moderna vaccine is actually the ionizable lipid-containing nanoparticles. So what's happening is you have a lipid vector, and it's stable at a lower pH. And once it gets into the cell, the pH is over 7, and you're actually seeing them dissipate and just leaving the mRNA sequence available in the cytoplasm for translation. This is seen with the COVID vaccines and then also some ongoing influenza vaccine trials. So there's multiple different variables that we can control in production of mRNA, which is eliciting different responses from the immune system, be it with the ribonucleosides that we use, the delivery methods, if we're using single-stranded versus double-stranded DNA, and then also sequence engineering with those untranslated regions that I talked about. And these are going to cause different levels, different amounts of cell activation from the immune system and cytokine releases. So in essence, the big differences between the traditional and mRNA vaccines, the components, you have mRNA versus the microbial protein or the microbe itself. The process is in essence the same. You're having it injected or introduced into the body in some mechanism, and it's stimulating an immune response. The big difference, though, is the production of it. The production time and flexibility with mRNA is a lot easier. For the mRNA, all you really need is a lab that can make an mRNA sequence, which are pretty common throughout the world. And you can just email the genetic sequence, so it's almost instantaneous. When you're actually having proteins, you need to set up the infrastructure for that. You need the appropriate equipment, which can be a lot more time-consuming and expensive. The United States actually has a program that's dedicated to the typical vaccines that we've seen. It's actually a secret compilation of egg chicken farms throughout the country, predominantly in the Midwest, where they have over 1 million chickens, which provides the U.S. with over 1 million chicken eggs a day, which are actually controlled to help fund and to help provide our flu vaccines that we have every single year. This is actually considered critical infrastructure and a matter of national security, and have significant physical and biosecurity measures that are assigned to these locations. The Department of Health and Human Services actually gives out contracts to companies to keep these locations secure. And this is on the order of tens to hundreds of millions of dollars a year. So now we're going to transition over to the new, the 2019 coronavirus vaccine. So one of the big concerns that we have is how has this transitioned from bench to bedside so rapidly? Most vaccines would usually take on the order of years to decades to get to market. And we've seen from the first genetic sequence being documented for the coronavirus back in January 10th of last year to the first trial vaccine being attempted in March 17th, and then the first person actually being vaccinated with a Pfizer in December of last year. So within about a period of 11 months, we went from the genetic sequence to a working vaccine. So there's actually two different points that this is just very simply put, but there's two different factors to this: the discovery period, and what we have is we have decades worth of work that was already done, that was quickly implemented. And then the remaining, the phase trials, the production, this was all just bulldozed through money. We had Operation Warp Speed, which was instated back in March of last year, where initially there was $10 billion being funded to these drug manufacturers, and then it was increased to over $15 billion. And this is what just the U.S. gave. This doesn't include the money that was given to BioNTech from the German government of almost $500 million. But what we saw with this was you had multiple phases running simultaneously. And once there was some promise in one of the vaccines, you actually started mass scale production a lot sooner than you would have seen it otherwise. And then this has also become one of the big issues with people who've even had vaccines in the past. They feel that this was very rushed and they feel uncomfortable getting the vaccine. And this seems to be just a general human psyche issue that happens, that, once we're taught when we're younger, patience is a virtue or good things come with patience. Even when we're searching for flights or car rentals on those websites and it shows you that it's searching for the best deal, we don't actually need that. Those are just those companies putting in that time lag because people perceive that they're getting a better deal when they have to wait for something. So in order to talk about the coronavirus, we have to actually go back a few decades from the beginning. So in the 1950s, RSV was actually discovered. And then in 1966, the NIH made the first vaccine, which was tested. And they were actually using formalin to attenuate the virus. What they noticed with this was that infants would actually develop antibodies, but there was no protection from the infection. And if anything, it actually made the disease worse. They saw hospitalization rates in infants of 80% that had been vaccinated versus 5% of the control. And 2 babies actually died from the vaccinated group. So this pretty much shut down any thoughts about RSV vaccine production for quite some time. And then in the early 90s, as technology continued to improve, they found that the F protein was actually what was used to infect and fuse with human cells on the RSV molecule. And it shapeshifts during infection. And this is very similar to coronavirus. So what was happening was when they were introducing it to formalin, they noticed that it was actually the post-fusion F protein that was found on the molecule and not the pre-fusion F protein. And this was leading to just poor quality antibodies being formed. And as a result, you were seeing increased inflammation, clogged airways, and disease severity as the clinical picture when they were actually contracting RSV after having gotten the vaccine. So in 2008, they renewed efforts to actually develop an RSV vaccine. And what they needed to do was they needed to lock the protein into the pre-fusion state and then also identify the shape of that. So they were able to do that with X-ray crystallography, and they ended up searching for neutralizing antibodies through patients who had already recovered from RSV. And they found that there were 3 potent antibodies that were available. Using X-ray crystallography, they figured out the crystalline structure of it, and they found that it actually fused with the tip of the protein itself. So when it was actually fusing with the membrane, that tip would disappear. And that's why those antibodies were pretty much useless. So they tried multiple different variants of this protein. And in 2013, they actually stabilized this molecule right here, the DSCAV1, which they made by just changing a couple of serine molecules to cysteine, which resulted in a disulfide bond, and then also changing a few residues within the cavity of the molecule itself, causing some hydrophobic residues to be developed. And this ended up causing a significant increase in the neutralizing antibodies that we found the immune response to. There's ongoing studies right now with Pfizer, Moderna, GlaxoSmithKline, and Johnson & Johnson in developing an RSV vaccine using this technique. But the big thing that we got out of this was the fact that protein conformation was actually a lot more important than just the sequence itself. With the MERS epidemic in 2013, they wanted to use a similar mechanism, and they found that the spike protein on coronavirus was actually very similar to the F protein on RSV. It was just 2.5 times bigger. They were unable to stabilize the MERS spike protein itself, so they actually went over to a related coronavirus with HKU1, KU1, and then they were able to better grasp images of this using cryogenic electron microscopy. So taking a look at the structure of it, what they found at the tip, similar to the RSV, was there's this 2 alpha helices that they had, and that in between there were a couple different amino acid molecules, specifically the asparagine and then the leucine. in order to stabilize it, because what was happening was these two alpha helices, when they were fusing with the host cell, would actually act as a spring and turn into one long one. So they wanted to prevent that spring from activating. So they just ended up adding two different proline molecules to this, and it just clamped that spring shut. If you look at figure D over here, both the MERS and the SARS virus, if you didn't make these proline changes, you saw that the electron microscopy images that you got were both the pre and post fusion state of the protein. While if you did the two proline caps, you had just pre-fusion molecules that were available. So this kind of brings us into COVID-19's vaccine development. Initially, for the antigen determination, when they were taking a look, they just used the S protein. They had already used it for research into MERS and SARS to begin with. They did notice that this bound to the ACE2 receptor with a much higher affinity than the SARS virus had, and there wasn't any cross-reactivity between antibodies against the original SARS, and then COVID-19. So with some just structural biology and protein engineering, they ended up stabilizing it with the same two proline moieties that were used right here at S2 prime. These red section is the two alpha helices, and this S overall is the spike protein that's being formed. And this is the basis of the Pfizer, Moderna, Johnson & Johnson, Novavax vaccines, this molecule right here. And as we can see, the pre-fusion spike right here is to the left, and this is what they had wanted to stabilize, and this is the post-fusion protein right here, which would not really render any good immune response if you were having antibodies form against that. There's already a second generation of COVID vaccines under development. That 2P molecule is pretty effective, but they do have a hexapro variant that they've developed, which is even more effective. This adds another 4 proline substitutions, which ends up rendering the protein more heat stable, works at room temperature. You can have more freeze and thaw cycles along with it. And the expression within human mammalian cells is about 10 times higher. So the research for that is underway, and the vaccine trials, I think, are about to start pretty soon. And this is, again, the hexapro variant. If you see this top ball and stick shape right here, these are the original 2 proline atoms that were, proline molecules that were changed, and then these are the additional 4 that we see. And these are the 2 alpha helices that are important. So now transitioning over to just controversy and hesitancy of vaccination. So the anti-vaccination movement has pretty much evolved concurrently with vaccines itself. There was significant opposition to Jenner's smallpox vaccine with the introduction of cowpox. This is just an artist rendering of what would happen just to scare people. You see their cows coming out of their nose or developing on their face. But the opposition that we saw to Jenner's smallpox vaccine was actually on multiple different aspects. Sanitary. They were just concerned that you were taking, you were just scoring the flesh of children. You were introducing this lymph from infected individuals. There was a big emotional component to it. They were just concerned of the invasiveness of the procedure and worried about their children or their loved ones. Religion also kind of introduced its head into this with thoughts of being unchristian or unnatural, of using an animal disease to help out humans. There's also a significant amount of distrust in medicine at that time, a significant amount of lack of knowledge in the theory of disease and how it's caused and how it's spread. And then also political issues. This was a violation of personal freedoms by government mandates of these vaccinations. So the UK is actually one of the big leaders of initial vaccine mandation and legislation. So in 1840, they're the ones who actually ended up developing free vaccinations for the public. They made it mandatory for infants up to 3 months old back in 1853, and actually instated a penalty for parents who didn't do that. So 128 pounds in today's dollars, so about $175. In 1867, they extended it to mandated vaccines for everyone under the age of 14. And with this, we also saw a significant introduction of different anti-vaccination leagues that came into play in the 60s, 70s. There was mass protests in the 80s. And then in the 90s, you saw them take a step back where they actually allowed parents to opt out, and then they removed the penalties also for mandated vaccines. The US, again, also it was just a few years behind the UK at this time. The first law that actually mandated children to have vaccines was back in Massachusetts in 1855. And shortly after we saw those anti-vaccination societies come into play in the UK, a lot of those individuals would actually travel to America and set up different anti-vaccination societies here also. And then in the early 1900s, we saw the Supreme Court through a couple of different cases uphold mandated vaccines and states and city rights to mandating these. So a couple of the more recent controversies that we've seen with vaccinations, the diphtheria, tetanus, and then whole pertussis, specifically this whole cell pertussis, was of concern back in the 1970s. In the UK, they actually ended up linking 36 children with neurologic conditions to this vaccine. Gordon Stewart was a prominent physician and then also anti-vaxxer of the time who published a case series making this link. And the repercussions in the US were a lot less. So we just had a couple documentaries and books come out with it, but we didn't really see a drastic change in vaccination rates with this specific vaccine. But the UK government ended up having multiple studies that came out trying to disprove it. The National Childhood Encephalopathy Study was the first one that came. They said that there was a very low risk, but suggested that it may rarely cause encephalopathy in patients who received the vaccine. However, a further review of the same data showed that they were unable to draw these conclusions because the N value was so small and they couldn't confer statistical significance. Subsequently, they followed up with these patients a couple of decades later to see if they had permanent neurologic sequelae. But again, they weren't able to determine if this was related to the vaccine or some other causes. But they did state that they thought that for the risk versus benefit, the vaccine was still more beneficial. And then in the early 2000s, we had another study. This was actually adequately powered, and it showed no link between encephalopathy, between the whole cell pertussis vaccine or the measles vaccine. But by this time, due to public demand, in the 1980s, they had actually made the acellular pertussis vaccine in Japan, and that's what we commonly use within the developed world now. Everyone remembers this or knows of this, the MMR Wakefield controversy linking MMR and autism. We all know that the study was retracted a while later. It had significant criticisms that were associated with it. Pretty much Wakefield argued that the live MMR vaccine ended up causing intestinal changes which released toxins and induced autism in these children. It was a very small sample size, only 12 children were involved in the study, and a lot of the data that they used was actually from parental observations of what the parents thought had caused these changes within their kids. There was significant financial conflict of interest. There was actually a lawyer that was working with many of these parents who saw this neurologic issues in their children, and they were actually suing vaccine companies to begin with, and he funded a big part of Wakefield's study. And then just a significant amount of professional misconduct. There was selection bias in the patients. There was unnecessary testing. A lot of these kids actually went through colonoscopies and LPs for the study. And a year before he actually published this study, he had actually applied for a patent in the UK for an alternative MMR vaccine, which he was advertising as safer and did not cause autism. And then greening our vaccines, taking out all of the additives or the partially harmful chemicals from it has been a big issue also. Thimerosal being the big one in the early 2000s. That was removed from all children's vaccines back in 2001. In 2004, the Institute of Medicine pretty much came out rejecting any causal relationship between the two, the thimerosal and autism. It is still found in some vaccines, specifically the multi-dose flu vaccines, just to use as a preservative. However, it's almost a negligible amount, about 25 micrograms, which is equivalent to if you consume 3 ounces of tuna. Mind you, there is a difference between ethyl and methyl mercury, the ethyl being safer. Now, switching over to vaccine hesitancy. So we always focus in on the patients who refuse all vaccines, and they are the most frustrating to deal with. But there is a big continuum of this, and this ranges from people who refuse but are still unsure and can be swayed into getting them, to people who just delay some of their vaccines and they're like, okay, we'll get it next time, and that these people end up never getting them. And then there's also a significant portion of people who accept vaccines but are just unsure of the complications of them. So multiple different factors are at play when this hesitancy comes in. First of all, there's just heuristic thinking. We all have this. This is all just a shortcut that we use to estimate risk. And this has just kind of been an evolutionary development for humans. And we perceive higher risks to threats that we can actively recollect. So this becomes the availability heuristic. There's also a spectrum bias that we see with vaccines having pretty much taken out a significant amount of infectious disease over the past several decades. We don't see polio, we don't see measles, we don't see mumps or smallpox anymore. So people perceive that the risk of the vaccine is much worse than the disease itself because they've never actually seen it. The act of omission is much greater than the act of commission. People are much more okay with having adverse outcomes happen if they did not do anything versus having received the vaccine and having had some adverse event occur. There's omission bias. We just overemphasize the risk of doing versus minimizing the risk of not doing. There's also just a perception that vaccines are unnatural and that natural immunity is a lot better. Just getting the disease is just going to be a lot better for you. We see this with some COVID parties that have happened in the past year. We see this with chickenpox parties that have happened for decades now. There's actually some parents who would actually infect different lollipops with chickenpox from their sick children, and they would actually disperse it to friends and family who wanted to introduce their kids to chickenpox and just get it over with. There's a big loss of public confidence also, just based on a lot of unscientific claims that are made on Facebook or social media or by celebrities who don't necessarily know what they're talking about. And then the MMR and autism study that we just talked about definitely didn't do us good with public confidence. If you take a look at the graph on the right-hand side, this is different reasons for refusal or alternative schedule that have been given to healthcare professionals. And as we can see, there's still a significant portion of the population that thinks that autism is linked with vaccination, along with the different added ingredients and then just different complications that can arise from the vaccine. We do see that there's a significant distrust of the pharmaceutical industry, but not as much of the government, which is going to come into play a little bit later. The success of vaccines, like I said, we don't see these diseases anymore, so we don't associate the fact that the vaccines actually helped eliminate them, and we think hygiene or whatnot is associated with it. And also, what we hold to be the interesting part of scientific evidence, the lay public doesn't necessarily think so. We refuse to kind of establish absolutes. I mean, besides for like the speed of light, there's actually very few absolutes within science. And as soon as we get new information, we can reverse our idea. We've seen this with the cholesterol guidelines. Is trans fat worse? Is saturated fat worse? Does fat, how much of an influence does fat play into the development of cardiovascular disease? With our PSA guidelines, with primary prevention using aspirin. These all change, but this doesn't help us instill public confidence. And then socioeconomic status. People from a lower socioeconomic status are just a lot less likely to be able to synthesize medical literature. They're a lot less trustful of the medical community. And we've seen this with African Americans, they have multiple reasons to be not trusting of the community, especially what's happened in the past, decades or past century. And then they just trust celebrities or social media a lot more than they do medical professionals. Looking at the graph on the right, we see that this is just a graph of the percent of U.S. adults that support universal vaccines. With the light blue, this is the percent that think that we should require all children to be vaccinated. And then the dark blue is parents should be able to decide. And as we see, the older generation is a much bigger proponent of having mandatory vaccinations, while the younger isn't, and they think that deciding is a better option. Mind you, most of the younger generation hasn't seen those diseases that we've eradicated. The nature of pharmaceuticals and biologic material is a big hesitancy factor. Also, we're comfortable knowing this, that not everything is going to be efficacious. With the H1N1 vaccine, you're going to have a significant portion, depending on what strain is active that year, we might be wrong and it might not be efficacious at all. Some vaccines are not going to work in a few percent of the people, such as the measles with the 2 to 5% failure rate. Some live vaccines can cause disseminated disease and immunocompromise. That's something that we're aware of, and we try to limit. But you can't get away from this. You can't get away from adverse reactions, despite how rare they are from happening. And then also just the temporal relationship. We also just think that if this happened after it, it's as a result of, causation and correlation. Autism is known to rear its head in children, and that same age as when we give them vaccines. We know that a lot of these vaccines cause fevers, and we know that children with fevers will often have febrile seizures, which doesn't necessarily cause any lasting damage, but it's seen. But people just associate the vaccine with this. It's also easy to kind of come under the misconception that, these people have no idea what they're talking about, or they just don't understand, or they're not logical. And we have to reason that people aren't going to necessarily use logic when it comes to this. There's a lot of anxiety that's associated with vaccines. You are vaccinating and introducing something foreign into your loved ones, into your children, so they're going to question it. A lot of medical professionals may not be most receptive to the questions that these patients have, or their lack of understanding to the importance of vaccines. And these patients can sometimes perceive this as us questioning their intelligence. And this will just end up driving them into like-minded communities where they are lauded for having done their research or trying to protect their children. And these beliefs are just validated and further affirmed. There's a significant suspicion of vested interest in vaccine promotion. And this isn't totally absurd either, seeing the fact on how much money the pharmaceutical industry makes and the price hikes that we've seen with insulin, and the fact that inhalers are insanely expensive. They know that these companies are making a lot of money, and they perceive that vaccines are in the same category as that. We're also seeing a significant increase in behavioral and developmental issues in children, be it from diagnosis, be it from some other cause that we haven't fully identified. And we commonly throw out hereditary into there. And this can feel like an attack to a lot of our patients, or a lot of the parents, because then they feel that they've had faulty genes. So just blaming a vaccine is a lot easier on the psyche. And then finally, we've also developed this era where it's shared decision making. We have warded away from paternalistic medicine. However, when it comes to vaccine, we're still pretty paternalistic that you need this vaccine. And this can sometimes be a turnoff to a lot of patients where they want to make that independent assessment themselves. This is just a graph which shows the percent of people in different areas around the world and what they feel about vaccine safety. And as we can see, the developing world in Asia, the Middle East, Sub-Saharan Africa is actually more likely to believe that vaccines are safe versus America, with the United States being almost just a little over 70%, with Europe and then the former Soviet Union. COVID-19 vaccine vaccine hesitancy is a really big thing, and this is going to be a really big problem, especially within the next month or two as we fully vaccinate the people who are willing, and now we run into those people who are much more hesitant or refuse the vaccine. What we're seeing as some of the main reasons for why they're hesitant, again, concerns about the side effects and safety of the vaccine, concerns that the vaccine was just developed too quickly, and then some of them are just waiting to see. The interesting thing is about 10% of people said that the main reason they're not getting the vaccine is because they don't trust the government, which we haven't seen with other vaccines. They might not trust pharmaceutical companies, but now we're actually seeing mistrust in the government. And that just kind of points out how politicized this has become over the past year and a half. Again, a similar chart just showing common reasons why people don't want to get the vaccine, but in this one, they were able to choose a lot more. They didn't have to just pick their main reason. And for this, we actually see that about 27% of people don't trust the government, and that's one of the reasons why they're not getting the vaccine. The vaccine distribution has been occurring at a pretty rapid rate. When you compare from December to March, 32% of people have already gotten at least one dose of the vaccine. The as soon as possible group is getting smaller, but that's also likely to the fact that they've gotten the vaccine. The wait and see group is getting smaller as they see more and more people getting the vaccine and not having complications from it. However, we see that the only if required or definitely not group hasn't really changed in the past 4 months, and it still accounts for about 20% of the population. There is a hesitancy also with the COVID vaccine and frontline workers. We see that people who are working in more acute care settings with hospitals and nursing homes are much more likely to get it than in home care or in outpatient clinics. We also see that people who are actively involved in the diagnosis and treatment, such as doctors and nurses, are much more likely to get the vaccine than ancillary staff involved in cleaning or housekeeping. But people still are looking to medical professionals when deciding to get the vaccine. Despite what race you are, almost 80% of people are still looking towards a doctor or a nurse to provide them information on getting the vaccine. So it is still very important that we put ourselves out there and mention it to all of our patients, especially the ones who haven't gotten it. There's a drastic difference between vaccination rates within Democrats and Republicans. If you look at the left, that's the Democrat graph. Between the people who've already gotten it or want to get it as soon as possible, almost 80% of Democrats are in that group, while only 46% of Republicans are. For the Democrats, only about 5% will not get the vaccine and have made it clear, while that number is almost 30% in Republicans. And this kind of presents the same information just on a state basis, where we see that the states which have larger urban populations or are blue tend to want to get the vaccine, while the ones that end up having a lot more rural populations end up warding away from the vaccine itself. As for which vaccine, it doesn't seem to matter. The people who want to get the vaccine don't care which one they're getting, and the people who don't want to get the vaccine don't care which vaccine it is. They don't want to get it. So what are some evidence-based practices that we can use to actually improve vaccination rates? First of all, we need to try to vaccinate our patients at every single visit that we see them. It's very common for us to talk about it during one visit and then just forget about it later. For HPV, they have noticed that if doctors or nurses had pushed for vaccines at every single visit, one study showed that it would be almost a 40% increase in the number of teen females who would have been vaccinated back in 2012. We also don't ascertain our vaccine status very well. We'll just ask the patients, hey, have you gotten your flu shot or have you gotten your pneumococcal shot? And they'll be like, yes, and we'll just take it at face value. We should ascertain that because people are just horrible at recollecting that. Using standing orders, I know we do that to a degree, but the patients not having to see us, but just being able to come in for a nursing visit and getting their flu shot or getting their COVID vaccine or whatnot helps improve compliance with vaccination. And it's also important in the inpatient setting. One study showed that having a standing order of everyone who came into the hospital for an influenza or pneumococcal vaccine, if they qualified for it, versus a reminder, they were significantly more likely to get it with a standing order. And that might be something that we might need to introduce with the COVID vaccine once it becomes more abundant. making clear recommendations, this still holds significant value. Parents who had their daughters vaccinated for HPV were 5 times more likely to recall that a clinician had recommended it. Also, using presumptive over collaborative communication. This kind of goes back into the lecture that Dr. Gilbert had given the fellows for smoking cessation, going in with the statement that we have to do shots versus what you think of shots. You are much more likely to have the patients receive the shots with the former than the latter. Comparing the odds ratio, it's almost 17.5 in the presumptive format versus the participatory format. And the patients who are hesitant, if the provider just continued to recommend their original recommendations, about 47% of hesitant parents actually went forward with the vaccines in one study. Of note, the presumptive format does lead to a lower rated clinic visit or just a visit experience. So, risks and benefits. Just kind of taking a look at this data. If you look at the participatory format, about 17% of patients accepted all the vaccines at the end of the visit in this one study versus 90% of the presumptive format. But when you look at the rating for the visit experience, 96% approval for the participatory versus just 64% for the presumptive. So we again see that patients do want to make those decisions for themselves, and they don't necessarily like that paternalistic practice, but they're a lot less likely to also get the interventions that we're trying to advocate for. Using the case method in order to address hesitancy, what this in essence is just corroborating, first of all, understanding the hesitancy that the patient has and trying to just identify a shared goal. So for us, in the next few coming months, it would be getting them to have the COVID vaccine. Then you kind of transition into your own professional standing and where you stand. You can provide personal statements, experiences, evidence that you found and looked into. Then you go ahead and summarize that evidence, and then you find common ground with the patient, and then you make your recommendation clearly heard, because that seems to be a big aspect on patients trusting us and actually doing the intervention. EMR prompts and alerts, these are super annoying and definitely a result of fatigue, but when done properly, can definitely improve outcomes. One study done back in 2018 showed that consistent EMR prompts that were done actually improved HPV vaccination rates by 8.6 per 100 patient visits. So the left versus the right, which is markedly improved. And then again, nothing new, patient rewards and incentives. People respond to money, people respond to rewards. And this study is back from 1984, but when they took a look at if you could just give a general prompt versus a specific prompt, or if you put the specific prompt with increased access to clinics or just a monetary incentive, the monetary incentive with the specific prompt was just the most cost effective in the short term. While just the specific prompt itself was the most cost effective in the long term. And it's kind of like attrition, you slowly wear them down. But at this point, if we link this with COVID, maybe having a monetary incentive on an insurance level or a government level might help those remaining 20% actually push forward with the vaccination. The other ones, just informing the patients about the side effects, letting them know that there is actually an adverse event reporting system that's in place. This actually tends to help improve acceptance of the vaccines if they think that safeguards have already been put in place. Having reminders and recalls, using the ancillary clinic staff to remind patients to come in, or having automated texts or emails that are sent out telling them to get the vaccines. Trust and time. Again, this is nothing new. You have to develop trust. You have to give it time. And then just giving them appropriate resources. There's a lot of information on the internet, and a lot of it is very difficult to sift through, but giving them the appropriate resources, which are actually evidence-based, can help also. So, taking a survey on patients and different things that would actually have them get vaccinated against COVID-19, we still see that if they're told that the vaccine is highly effective, they're told that this will protect them and their loved ones. They're told that this will help them transition back to a normal life. They're still willing to listen. And these are big factors that will help shift them into actually getting the vaccine. And just dispelling a lot of false statements about the vaccine is important. Almost 20% think that the vaccine contains the live virus. Another 12% thinks that this causes infertility in people. And another 12% think that the vaccine actually costs money. So we have to dispel a lot of these fallacies that are associated with the vaccine. So the Ad Council, which has been the public service campaign, has done these different public service campaigns, has come up with It's Up to You, the new COVID vaccine campaign that's ongoing. And that is it. Any questions?
Thanks, Sunny. I was just, when you were talking, I was wondering if the hesitancy behind vaccines has gotten worse since in the past, when was the internet invented? 20 years ago, 30 years ago? Anyway, with the
yeah. So there's I don't know if it's necessarily associated with the internet. It probably is, but there's definitely a lot of graphs and information out there that shows that hesitancy has significantly increased in the past 20 or so years. So pretty much where the internet became very common to the public.
Yeah,
because there's just a lot of information.
Yeah, I mean, the patients that I have, and I have kind of started doing like what we talked about with tobacco cessation, instead of being like, do you think you'll want to get the COVID vaccine? Instead of just being like, what's your plan for the COVID vaccine, right? And it's very interesting to hear what people will say. And the people who will say, oh, I read on the internet that 150 patients have died after the vaccine. And you're like, really? And, you have to kind of sit and talk through that. But yeah, I mean, I think the internet is a significant barrier for us, especially in our younger population. But it's very interesting. So thank you.
Sonny, great talk, man. I just want to share. So I was moonlighting at a hospital this weekend in an area that's really hit that hard right now by COVID, like Ingalls Hospital, and they're full of COVID. And I ran into a physician in the physician's lounge who I didn't know, who cornered me. He actually, I think, trained here. And he told me about how the vaccine was a push by pharmaceutical companies and how we're not giving ivermectin and we should be doing the MAF1. So it's not just it's us too, I think, and especially social media and all of that. I think it's a lot to combat. And like you said, people will go to whoever is saying what they want to hear is what people will turn to. This guy is practicing in a community that has a lower vaccination rate. It's just, it's scary and it's sad, I think.
Yeah, for sure.
Yeah, one person like that or one Scott Atlas is enough to give, let's say, ammunition to people that want to believe something counterintuitive, counter-logical.
Yeah.
I guess the other thing that's in the news is that Astrac, I forgot how to say that company's name, with the blood clots.
AstraZeneca?
Yeah, did you
what
see
about that?
It has a rare cause for a certain
blood clots.
It's rare, and I think the numbers that I saw is still comparable to the blood clot rate in the general population, but the media is on that, especially in Europe. So
yeah, it's kind of interesting because the AstraZeneca vaccine, while it's not using mRNA technology, is just using that same proline, the 2 proline substituted protein. This protein actually was developed out of the University of Austin. And they're using the exact same thing. This is pretty much the predominant protein that's being used in most vaccinations around the world right now. So, I don't know. Honestly, I haven't read too much about the clot risk between that vaccine versus just the general public. But we'll just have to see.
Sonny, did you come across any data for what to do with and Brad and Dan, you guys might have this too, what to do with our patients on immunosuppression? I think there was March 15th, that JAMA article that talked about how, I think it was JAMA, right? Which talked about solid organ transplant patients had lower rates of an immune response But what about our patients that are on like, immunosuppression for sarcoidosis? Should we be holding with the mRNA vaccine, their immunosuppression? It looks like no, but, it's just, there's not, I think American College of Rheumatology was going to put out a statement or something on how to guide us what to do.
So for the ECR, it's you continue everything except for the Rituxan, things that would affect the B cells. So at least for my sarcoid patients, they continue methotrexate, Celsep, prednisone, all of that. I don't have anybody on Rituxan, but even the TNF alpha inhibitors, they I think they're okay to hold. I don't know about Brad and Dan from the transplant standpoint, but that's what I've been doing for my sarcoid patients.
Yeah, the ICHLT has put out a statement basically saying that all patients should be vaccinated, perhaps with the exception of people that are freshly transplanted and highly immunosuppressed, where you might delay it until a point when the immunosuppression has waned a little bit. Any of the concerns around potentially revving up the immune system and causing acute rejection, or I guess some of the same things exist in the rheumatology space around revving up the immune system and making disease worse. I don't think those things have borne out, at least not in any significant way. Whether it is less effective in people who are immunosuppressed is a lingering question. It's probably true, but that's not to say that you shouldn't vaccinate people. It's just that you understand that the vaccination may be less likely to provide as robust a protection from either infection or serious infection. But everyone should get vaccinated, whether it's whether they're transplanted or not. The JAMA article also showed us, at least suggested to us, that there's a less robust antibody titer response in patients who are on Cellcept or azathioprine, the cell cycle inhibitors, and that was all solid organs. So it was in kidney. A lot of people aren't on those things anymore. So the people that are on those things maybe don't get as much antibody response as the people that aren't on them. But I don't think it's worth risking their graft in order to try to get a vaccine in them. So we keep going with the immunosuppression. We give them the vaccine, and we hope for a good response. And the last part of this is that antibody titers are not the only, let's say, measure of effectiveness of a vaccine or protection of a vaccine. There's T cell response that's not being reported, measured in a lot of these things, and not easily checked in a lab. That is probably a maybe even more important part of protection from the vaccines. And who knows whether their antibody response, their T cell response is maybe more similar to the general population. We don't know that. Actually, the Johns Hopkins group is actually looking at that on an ongoing basis. So I don't know, that's a lot of stuff, but basic answer is, yeah, vaccinate everybody all the time, all day.
And I will say one thing that I learned a couple weeks ago. Apparently, the arm that you get vaccinated in, you can get like a big axillary node that persists for a week after. And so I was talking to Lebowski about it, and he said that they've done there's been a lot of lymph node biopsies on these big lymph nodes in people who had recently gotten the vaccine, and they're all obviously negative. And so I had a patient who had a CT and a big node in his axilla, and whatever, concern for lymphoma, blah, blah, blah. And I talked to him about it, and the guy had just gotten a vaccine. So we're holding off and repeating a CT in a few months or something like that to see if it persists. So just something to be aware of.
I think they're also recommending some time interval between COVID vaccine and mammograms as well for the same reason.
I heard about that too. Yeah, that's true. Yep. Okay. All right. Thank you, everyone. It's 1 o'clock. Thanks for joining. Thanks, Sunny. Great job.
Thank you.